Welcome back, guys. In this video, I wanted to look at a T-beam. So here we have a T-beam and it's got two rectangular components. Now, you'll notice that there's no neutral axis drawn in this diagram, and that's because we don't know where it is. Unlike the I-beam example that we looked at previously, that was a symmetrical object, so we knew that the neutral axis was simply straight through the middle. Yet we don't know where this this neutral axis is going to be. We can assume it's over here, right? We assume that it's over here. We call this the neutral axis. But we need to know what this value is here, okay? And that value there is known as y bar. Okay, so the formula for y bar, that is the sum of the y bar for each individual rectangle times by the area divided by the area. Okay, so we'll have to repeat that exercise for both rectangle 1 and rectangle 2. So for rectangle 2, the y bar is simply going to be that distance there. Okay, so if we start from here and we're going up, what's that distance there? That's simply going to be 30 divided by 2. Okay, so that's 15 times that by the area of this rectangle. 30 times 150. And what's the area? It's also going to be 30 times 150. Okay, so that's shape 2 done. Tidy it up with some brackets. Extend the divide plus. Okay, shape 1. What's that y bar going to be? So we got to think a little bit carefully about this one because we're going to have to accommodate for this distance here, 30. Okay, and what's this y bar here going to be? That's simply going to be 150 divided by 2, isn't it? That's 75. So that there is going to be 75. From the edge of this rectangle to this centroid is 75 plus the 30 here. Okay, so let's do that. 75 plus 30 times that by this area, rectangle 1, which is 30 and 150. And pop that in the denominator as well. Okay, so that's our y bar, which is 60 millimeters. Okay, so now we know where this neutral axis actually lies. That's important for our second moment of area calculation. So let's get rid of some of this stuff here. Don't want to confuse ourselves. Okay. Ix equals 1 over 12 base height cubed plus parallel axis theorem AD squared. Okay, so we're going to have to apply this parallel axis theorem for both of our objects now, because as I said, they're not sitting on this neutral axis. They're off center, basically. So let's do that for both of our rectangles, starting with rectangle 2. 1 over 12 times by this base, 150, times by this height, 30, cubed, okay, plus parallel axis theorem. So what's the area for that? 150 times 30, okay, and then we need to times this by this distance, so from this centroid to this neutral axis, okay, so that's simply going to be 60 minus this distance here, which is simply going to be 15, okay, and that's squared. Let's tidy this up with some brackets and move on to the second rectangle, which is rectangle 1. Same thing, 1 over 12 times by the base, which is 30, times by the height, which is 150, cubed, plus parallel axis theorem. So area is 30 times by 150, okay, and now we're going to have to calculate this distance. It's this distance here from this centroid of rectangle 1, from this y bar. Okay, so how are we going to do that? So we know that the rectangle 1 is 150 in length. So half of that is going to be 75. So that's from here to here. That's 75. Okay, and this length here is going to be 30. Okay, so we know that this distance to the neutral axis is 60. So all we have to do is add this to this and subtract 60. Okay, so 75 plus 30 is 105. Okay, and we're going to minus 60, and that is squared. Tidy it up. Pop that in the calculator, and I believe we get 27 times 10 to the 6 millimeters to the 4th.